All right, and I'll also start the screen share with the whiteboard. Okay, and now I will move things around because these taskbars or toolbars occupy part of the place where I try to write, and also where we are. I scoot us a little to the right, scoot the one taskbar down, the other taskbar up and to the right, and then I move the whiteboard as far to the left and up as I can to get maximum white space for me to write. I think all you see is white, but I have a limited amount of white. Okay, I think we're at we're in chapter 1, systems of linear equations, in section 1.2, Gaussian elimination and Gauss-Jordan elimination. And what we talked about before was using your elementary row operations to get your system of equations, or at least the matrix of the system of equations, okay, in what they call echelon form. And that was that stair-step pattern, only it's going down or doing some sort of strange way. What it is, you want the first upper left element to be a 1, zeros below that. On the second row, first non-zero element to be a 1, zeros below it. The third, the next one, row, first non-zero element be a 1, zeros below that. So you see, if you're walking on your leading ones, you would be walking on them like this, stair step. Okay, zeros all below it, so you're walking on air. No, it sort of seems like the staircase is turned upside down, and it would be better the other way. But this is what we mean by echelon form. It refers to the stair-step pattern formed by the non-zero elements of the matrix, only they're kind of reversed. Okay, now the example we did last time, which I think was example 3, we got that into echelon form. We did finish example 3, didn't we, last time? Do you recall? On page 15? Okay. Now, that was in row echelon form. Okay, I keep wondering if the guys are going to show up. So far they haven't, but let's continue. I am recording so they can pick this up. Now, there is row echelon form, and then there's another kind that's called reduced row echelon form. Now here's the difference. Row echelon form, leading ones, zeros below it. Leading 1, zeros below it. Leading 1, zeros below it. Okay? Reduced row echelon form, leading 1, 0 below it. Leading 1, zeros below and above it. So all you have is a 1. Okay? Then the next row, leading 1, zeros above and below it. So all you have left in that column is the leading 1. And you keep going down that way until all you have. Now, you may have some rows that have, say, several zeros before you get to leading 1. Well, those zeros won't necessarily have zeros above and below it. Only leading ones have zeros above and below. That's called reduced row echelon form. Now, I can't remember, did everyone have a book? Do you recall? Or did some of them still not have a book? I don't remember either. There's only 3 of you. Oh, here comes one right now. Here comes James. We can ask him. I think he was waiting on his book. So let's see if he's gotten it yet. James is here. All right. So we're only missing Jesus. But Jesus was absent yesterday too, so I hope he's not got some problems. So James, you able to hear us yet?
Yes, sir.
Okay. Do you remember if Jesus had a book or not? Second,
I know what you said.
did you remember if Jesus had a book or not?
No, no, sir, I don't.
Don't remember. I don't remember either. I think he did. Did you ever get your book? Or are you still waiting on it?
Yeah, I got it, but I'm using my phone right now.
Yeah, oh, I see. Okay. So you can't see your book. Okay. That kind of answers the question. What I think I'll do for purposes then, I'll actually type out this stuff. It's easier to read my typing, though I do make typo errors, but I can correct those easier than I can writing. So I'll type that out. But first, it's at least 2/3 of you are here now, and Jesus didn't make it yesterday to a class, so he may be have an issue or something. So let me go on and confess to you what went wrong last Thursday. Remember, last Thursday was the first day that we had Screencast-O-Matic back. I was so excited to have it. I recorded my first class and got it uploading and stuff like this. Recorded my second class, got it uploading and everything. Recorded this class. Now, I don't know if you recall, but I think your loudmouth instructor went on too long and started getting short of time, and one of you reminded me, hey, you're running out of time, or we already passed time, or something like that. Or maybe y'all had some questions too, I don't remember. But I got into a rush, and because it'd been so long since I had had it, I forgot to end the recording. I was recording the class, but I forgot to end it. Because I only had 30 minutes for lunch between this class and the next class. I mean, only it. And I'd already eaten up, so to speak, part of my time. So I got in a rush and I went down, forgot to turn off the recording. So for those 30 minutes, then it was just dead time up here, nobody here. Then I came back up and I was running a little late probably, so I rushed around getting everything loaded for my next class. When I started the class, at some point I thought, wait a minute, did I turn on the recorder? I looked down and it was recording. I said, yes, I did. What I didn't realize, I had never turned it off from your class, okay? So what I was doing was recording their class after your class with a 30-minute lunch break in between. So at the end, and theirs unfortunately is a 4.5-hour class, and it took just about that long to do it last time. We had a lab. The class is 2.5 hours because it's a mini term, and then the lab, which is another 2 hours, and we took just about the full time. And then at the very end, I went to close it out, and I noticed it was a more than 5-hour class, almost 6-hour class. I went, oh no. So I can only give it one name. Now, supposedly, you're supposed to be able to edit the files, but I've never been able to edit the files without losing something. So I decided rather than trying to struggle through that and wind up losing stuff, I just put both of those files in. I'd already named it by the time I noticed it, PHS111 chapter 16 lab 2 or something like that. I'd already given it a name, and I was saving it to their to YouTube for them, but I went on and saved it to YouTube for you too. So if you go out to the YouTube playlist, you'll see that in addition to all the MTH237s, you have a PHS111, okay, 111. That, the first hour and 15 minutes or so of that recording are yours. That's your recording. Once you get to the end of the class, you can ignore the rest of it. You don't want to sit and listen to it. You can listen to it if you want to. It's out there, okay? Now, how am I going to have to tell the next class when we meet at 1:15 that they are going to have to skip through the first hour and 45 minutes or so until they get to the first of their class, and then at that point they'll be able to listen to everything else. You can fast forward or move your thing on it. Y'all know how to operate things like that better than I do. So anyway, that's my embarrassing story for the day. Hopefully I won't make it. So what I'm asking you to do, please, at the end of class, remind me, have you turned off the recording? Ah, here comes Jesus. He's here. That's good. So we got everybody here, and now I need to go over that again with him. Okay. So let me, oh, Jesus, you already in there so you can hear me? All right. I was just telling the others I really made a big boo-boo at last Thursday's class. We finally got Screencast-O-Matic back. I was so excited to have it, but at the end of class I had gone over, and I think maybe someone had some questions, and we talked about stuff. I only had 30 minutes for lunch, and I got into a rush and ran downstairs to eat lunch, forgot to turn off the recording. So your class got recorded, but then it also had 30 minutes of dead time. Well, I rushed back upstairs after 30 minutes of lunch and tried to get set up for the next class. It has more things I have to set up than yours does. And they have PowerPoint, and we had labs, and had a variety of things. So I rushed to do that and got into the class. And I thought, did I ever start the recording? I looked down, and yeah, it was still recording. I said, fine, good deal. I didn't realize it was still your recording. So I recorded there 4.5 hours after your hour and 15 minutes and the 30-minute lunch break. All that was on the same recording. I didn't notice that till right at the end of the class when I went to save it, and I saw it was almost 6 hours of recording. I said, oh no. So if you go to the YouTube video link to the playlist, you'll see on your playlist a bunch of MTH237s, all the sections that I did last summer, all the sections that I've done so far this time, which is only one, I think, and a few others from other times. They're all out there, but you'll see one that says PHS 111. Okay, the first hour and 15 minutes of that are yours. The rest of it, after we end the class, you can stop the recording and ignore the rest. Okay, you're welcome to listen to it if you want to. There's 30 minutes of nothing, and then you'll have 4.5 hours of physical science. If you want to listen to it, it's there. It's on your playlist. You don't have to. Only pay attention. I've got to tell the next class, ignore the first hour and 45 minutes. Get started where we got started and go on from there. So that's my embarrassing story for today. Now, since all of you are here, we're in Chapter 1, Systems of Linear Equations. Oh, and the moral for that story is, at the end of class, remind me to turn off the recording because I get so eager to get down to lunch. I forgot it last time. I'll try not to do it again, but you remind me. Okay, and also keep up with the time. Okay. We're in Chapter 1, Systems of Linear Equations. We're now in 1.2, Gaussian elimination, and Gauss-Jordan elimination. Right at the bottom of page 15, I think we finished example 3. I was just talking with Kara before the two of you came in. The difference between row echelon form, which has a leading 1, first entry in every row is first non-zero entry in every row is leading 1. Under that are all zeros. Next row, first non-zero entry, a leading 1. All below that are zeros, and then you keep going like that, so you have a stair step of leading 1s, okay, with zeros below them. Okay, now there is also something called reduced row echelon form. In that one, for every leading 1, not only do you have zeros below it, you have zeros above it. If there's anything above it, there's zeros also. Only in that column though, okay? That would then be reduced row echelon form. And James is on his phone, can't look at his book now, so I'm going to type in, and this will take a while, and it's not going to be pretty or fast or anything else, but I will type in the text of what you need to know about reduced row echelon form. Okay. A matrix in row echelon form has the properties below. Okay. That's supposed to be a period. All right. 1. Any rows consisting entirely of zeros occur at the bottom of the matrix. That's pretty ugly, isn't it? That is really ugly. Okay. For some reason my space bar wasn't doing a very good job. Okay. I thought I'd gone to the bottom, but I can't get there. All right. 2. I'm supposed to capitalize. For each row that does not consist, I can't spell, entirely of zeros, the first non-zero entry is 1. That's what I've been calling, and they call a leading 1. Okay, I'm not checking all my things. 3. For 2 successive, and these are non-zero, rows, oops, the leading 1 in the higher row is farther to the left than the leading 1 in the lower row. All right. A matrix in row echelon form is in reduced row echelon form when every column that has a leading 1 has zeros in every position above and below its leading 1. All right, let's string this thing out, make it a little easier maybe to read. All right, let's see how bad the writing is. These are not properties, they're properties. Okay. Matrix in row echelon form has the following properties. If you do have a row that turns out being entirely zeros, they have to go to the bottom of the matrix. Use your elementary row operation, get it to the bottom. Okay. For every row that does not consist entirely of zeros, the first non-zero entry is a 1, and it's called the leading one. And for any two successive non-zero rows, the leading one in the higher row is always further to the left than the one in the lower row. Okay, so in other words, the one in the lower row is always to the right of the one in the upper row. And for two consecutive non-zero rows, the leading one, oh, I already said that. Yeah, okay. Now, a matrix in row echelon form is also in reduced row echelon form when not only every column, now we're talking about the columns with the leading ones in it, has zeros not just below it, that would be row echelon form, but below and above the leading one, that would be reduced row echelon form. All right. Now, here we'll see some matrices. I'm not going to type these in, I don't think, okay? I will write these in. So let me get my pad and do that. Okay, if I can get my place here. Determine whether each of these is in row echelon form. If it is, then see if it's also in reduced row echelon form. So here's A. Well, I thought I had my drawer, but it didn't seem to draw. Okay, here's what we have. 1, 2, -1. This is ugly, isn't it? 4, 0, 1, 0, 3, 0, 0, 1, -2. Okay, first question. Is that in row echelon form? Yay or nay? Anybody? Anyone? Yes, it is, because you see there aren't any rows with all zeros, so that's okay. The first non-zero entry in this row is a 1, zeros below it. First non-zero entry in this row is a 1, zeros below that, and then the first non-zero entry in this row is a 1. Now, the ones step down left to right, if I could get my pen. Here, here, here. Stair-step model. Row echelon form. Is this in reduced row echelon form? Yay or nay? Anybody? No. Okay, yeah. Okay. No, because look, this first leading one, where am I? Okay, has zeros all below it. That's fine. The second one has zeros below but not above. So this 2 would just by itself knock it out of being reduced row echelon. But not only that, this leading one has a 0 above it but not here too. So the -1 also knocks it out. Wouldn't be hard to get this into reduced row echelon form. You could just add -2 times row 2 to row 1, that would make that a 0, and add row 3 to row 1, that would make that a 0, then you'd have it in reduced row echelon form. But it's not there yet. Let's look at B. Okay, B is another 3 by 3. It's a 1, 2, -1, 2. Almost the same as before, but not quite. A 0, 0, 0, 0. And a 0, 1, 2, -4. Is that in row echelon form? Yay or nay? Why not? All zeros should be at the bottom. All it would take would be to swap these two rows. And then you would have it in row echelon form. If you did that, would it be in reduced row echelon form? Yay or nay? No. Why not? Because here is a leading 0, a leading 1, zeros below it, that's fine. But this leading 1 has a 2 above it. It needs to have a 0. Of course, we swap these two rows to begin with, put the row of zeros at the bottom, but then this 2, all we'd have to do was multiply this row by -2, add it to that row, then we'd have it in reduced row echelon form once we had swapped those two rows. Okay? So it was neither row echelon form or reduced until we did some adjustments. Number C. Now C is a lot bigger one. Okay? C is 1, -5, 2, -1, 3. Okay? Row 2, 0, 0, 1, 3, -2, 0, 0, 1, 3, -2, 0, 0, 0, 1, 4, 0, 0, 0, 1, 4, and 0, 0, 0, 0, 1. Okay, is that in row echelon form? Yay. Say again? Yes, it is. Leading, the first non-zero entry here is a 1, all zeros below it. The first non-zero entry here, you have to go over to column 3 before you get there, and it has zeros below it. Leading non-zero entry in row 4, you have to go over here, it has 0 below it. The leading non-zero entry in row 5 is a 1, there's nothing below it. So that's in row echelon form. Is it in reduced row echelon form? Yay or nay? No. Why not? Not because you don't have a leading 1 here, it's because you don't have a 0 here, or here, or here. Okay? So you got a lot of work to do. It's not hard work, but you got work to do before you get it in reduced row echelon form. Now, okay. So let's go on to D. Here is D. Okay. It's a 1, 0, 0, -1. 1, 0, 0, -1. 0, 1, 0, 2. 0, 0, 1, 3. And 0, 0, 0, 0. Okay, first question, is that in row echelon form?
No.
Why not?
Because the bottom is 0.
Okay, but that's okay. Up here, any row consisting entirely of zeros occurs at the bottom of the matrix. If it occurred anywhere else, no. But at the bottom, yes, that's perfectly fine. So that wouldn't knock it out. Now, again, is it in row echelon form? Yes. Okay. Second question, is it in reduced row echelon form? Yes, again, very hesitant. Yes, but it was a yes. Okay. Because row echelon form requires that every first non-zero entry in a row be a leading 1, zeros below it, 0 below it, 0 below it. For reduced row echelon form, not only 0 below it, but also zeros above it, and this one doesn't have a leading 1. Now, The other thing is that they have to stair step down. So rows of all zeros at the bottom are okay for either. Rows of all zeros in the middle, not okay. Okay. It's all right to have, if you don't have a leading one, you can have non-zeros above it, obviously. So that one's both row echelon and reduced row echelon. E. Okay. E is a 3 rows, so it's going to be a little smaller. 1, 2, negative 3, 4. 0, 2, 1, negative 1. 0, 0, 1, negative 3. Question, is that in row echelon form?
No.
Why not?
There's 2.
That second row, the first non-zero entry is not a 1, it's a 2. Real easy to get that into row echelon form. Divide everything on the second row by 2, and you've got it in row echelon form. That would be a 0, 1, 1/2, negative 1/2. That would be row echelon form. Is it in reduced row echelon form? Well, of course not. It's not in row echelon form, so it can't be in reduced. But the other reason it can't be that, even if you did make that change, you still got a 2 here and numbers above this leading 1. So that wouldn't be in reduced row echelon form either. Now F. F is 0, 1, 0, 5. 0, 0, 1, 3. And 0, 0, 0, 0. What you think? Is that in row echelon form? What was that? Is that? It is in row echelon form. Now, it's bizarre, okay, I'll admit that, because that leading column, the first column, is all zeros. So basically that tells you you're getting absolutely, well, okay, number one, this doesn't have to represent a system of equations. If it did, basically what's that telling you? The first variable has no meaning whatsoever, okay, because all its coefficients is 0. But this doesn't have to be. This could just be a matrix, and it is a matrix. It is in row echelon form because the first non-zero entry in this row is a 1, 0 is below it, 1 here, 0 is below it. There are no non-zero entries in this row. So it is in row echelon form. How about reduced row echelon form? It is also, because this only other leading one has a 0 above it as well. So that is both row echelon form and reduced row echelon form. It's just a rather bizarre matrix. Okay, so A, C, D, and F are in row echelon form. Okay, where is it? Where's my pen? There it is. This is row echelon form. That one's not. This one is. That one is. That one's not, but this one is. So A, C, D, and F, yes. The matrices D and F, this one, and this one are the only two in reduced row echelon form. Very good. Now, there's a little technology blurb in the left-hand column of page 16 on a technology guide. Read that if you're interested. It has to do with Cengage's, I hate their terminology, CengageBrain.com but you can access some of these utilities there. I think if you bought into Cengage Unlimited, you should have access to this. If you just have a code, you should be. If not, I don't know. I don't know how Cengage works. All right, then continuing down the page on 16, every matrix in row is row equivalent to a matrix in row echelon form. Get that. Every matrix is row equivalent to a matrix in row echelon form. Sometimes you have a lot of digging to do to find it, but you can do it. For instance, in example 4E, that's this one right here, okay, we already said all you have to do is divide the second row by 2 to get it in row echelon form. So every matrix can be given. This one, all you had to do was switch these two rows. That would work. So every matrix is row equivalent to a matrix in row echelon form. Okay. The procedure for using Gaussian elimination with back substitution is summarized below. Now we've done that enough times. Do you need me to type it in for you? I can do it. It's a little slow, but I can do it. Or I can just read it to you if that will be sufficient. Would you rather me type it or just read it? Anybody? Type or read? Just read. Okay. Now, Gaussian elimination with back substitution. Write the augmented matrix. Now, this is assuming we have a system of linear equations. Write the augmented matrix of the system of linear equations. We're used to doing that. Okay. Use the elementary row operations to rewrite the matrix into row echelon form. We just said every matrix will do that, so do it. And then number 3, write the system of linear equations corresponding to the matrix in row echelon form using back substitution to find the solution. So we've done that before. Let's just imagine that first equation, that first matrix up here, we've already got it in row echelon form. This would tell us z is equal to -2, y is equal to 3, and then plugging those values in here, -2 here, 3 there, 1 plus 6 plus 2 is equal to 4. Then do back substitution. You can figure, I'm sorry, this was x, okay, x plus 6 plus 2 equal 4. Subtract 6 plus 2, 8. X is equal to -4. That's what we mean by back substitution. Now, Gaussian elimination with back substitution works well for solving systems of linear equations by hand, or it's fairly easy to program into a computer. Easier if you already have it programmed in. Okay, for this algorithm, the order in which you perform the elementary row operations is important. Operate from left to right by columns using the elementary row operations to obtain zeros for all entries directly beneath the leading ones. That's what we've been doing. You keep doing it. We're going to do example 5 in a minute, but here's another linear algebra applied illustration, bottom of page 16. GPS, Global Positioning System, is a network of 24 satellites. I didn't know there were just that many, 24 satellites, originally developed by the U.S. military as a navigational tool. I actually was on board a ship when we first had, we call it, back then they didn't call it GPS, they called it SAT-NAV, Satellite Navigation System. When we were just installing the first antenna of SAT-NAV on our ship. I don't think we ever got it completely loaded. We're going to do that when they went into the yards, and when we were doing one of the drills that we had to do before we could go into the yards to check out all the systems, we had a anchor windlass brake that didn't break. The anchor end of the anchor chain came flying out of the hose pipe and crashed and broke a lot of the sat-nav computer antenna. We had never even hooked it up. We didn't quite destroy it, but we did a good job of doing that. So anyway, that's a naval story. But anyway, guess what? Linear algebra is used for you to determine your position. They automatically, the algorithms solve how far you are from this satellite, how far you are from that satellite, how far you are from this satellite. That puts you right there. They may use more than 3, but you got to have at least 3. Okay, and that tells you precisely where you are. Okay, so let's do example 5, Gaussian elimination with back substitution. We've done them like this before. Let's do it again. Now this is going to take some writing. Oh, look at that. This is supposed to be in every position, not position. I don't know what that is. Probably can't get that to come back now. But anyway, that's position. I just noticed that. All right, let's clear that slide so you won't notice any more of my typos. Okay, now here's example 5. It's going to take me a while to write it. Fairly complicated system. Okay, we'll start with x sub 2 plus x sub 3 minus 2x sub 4 is equal to negative 3. Sometimes the pen works well and sometimes it doesn't. Second equation, x sub 1 plus 2x sub 2 minus x sub 3. Find if I slow my writing down it helps a little bit. That's equal to 2. Next equation, 2x sub 1 plus 4x sub 2. See, that doesn't like to write 4s. Plus x sub 3 minus 3x sub 4 is equal to minus 2. And x sub 1 minus 4x sub 2 minus 7x sub 3 minus x sub 4 is equal to negative 19. Okay, y'all check me and make sure that I'm not copying something wrong. I'm having to look at the book in my lap, write on a tablet in my lap, but watch the board up above, otherwise nothing works. All right, first thing we do, anyone want to make a suggestion? Hint, write the augmented matrix without the variables. Okay, coefficient of the x of 1 here, 0. Then you have a 1, 1, minus 2, 3, or negative 3. Next, 1, 2, minus 1, 0, 2. Next, 2, 4, 1, negative 3, negative 2. Next, 1, minus 4, negative 7, negative 4, no, negative 1. Yuck. Negative 19. Okay. Check me, folks. Make sure I'm not doing something stupid. Because I hate to get deep into the problem and then find out I copied something wrong. Been doing all the steps right, but they were the wrong steps. All right. Now, what's your suggestion for what we do next? Yuck.
Don't we have to make the top, the first one, a 1?
That is ideal. Okay, so how do you suggest we do that?
I'm not sure.
Okay, how about just exchange these two rows? Remember, that's one of your elementary row operations, exchange two rows. That would give you a 1 there. Okay, so let's do that. This is a lot of writing of the same numbers over and over and over. Okay, so that will now become 1, 2, minus 1, 0, 2, then a 0, 1, 1, minus 2, minus 3, that's ugly, 2, 4, 1, minus 3, minus 2. That will not write. Okay, there we go. 1, negative 4, negative 7, negative 1, negative 19. Okay, my columns are getting a little shaky there. All right, what would you recommend we do next? Let's go back and see what we want and what we got. We wanted a 1 here, that's why we did this. We got a 1 there. What are we going to do with that leading 1? We want all zeros below it. So let's use that leading 1 to make this a 0. How do we do that? Minus 2 times row 1, add it to row 3. You see, that's supposed to be a 3. It's just not writing. You already got a 0 there. Don't have to do anything. So that means, guess what? We just copy down again. 1, 2, minus 1, 0, 2. And 0, 1, 1, minus 2, minus 3. Now, operating on the third row using the top row, negative 2 times 1, negative 2 plus 2, 0. That's exactly what we want. Then, negative 2 times 2 is negative 4 plus 4. That's also a 0. Then, a negative 2 times negative 1 would be a positive 2 plus 1 would be a 3, I believe. Check me if I'm wrong. Okay. And then a negative 2 times a 0 is a 0 plus a negative 3 would be a minus 3. And then a negative 2 times 2 would be a negative 4 minus 2 is minus 6. Okay. Now, we also want a 0 here. Then it's just minus row 1 plus row 4. That will do it to us. We always use those leading 1s to get zeros below them. Okay, so here we go. Minus row 1, that's minus 1 plus 1 is 0. Minus 2 minus 4 is minus 6. 1 minus 7, that's also a minus 6. 0 minus 1 is a minus 1. And minus 2 minus 19 is minus 21. This is getting worse looking. This is so aggravating. Okay, let me make sure I haven't done anything stupid. I think we're at the same place they are, so if I did, they did. Okay, yeah, I think we're okay. What do you want next? Let's just review what we got. We got a leading 1 here, zeros below it. Go to the second row. Hey, we already got a leading 1. First non-zero entry is a leading 1, but what do we want now? All we're asking for is Gaussian elimination and back substitution, so we only need to look down. Okay, so what are we going to do? This is already a 0. We want the minus 6 to become a 0. How do we make that happen? 6. Yeah, 6 times row 2. Use that leading 1 and add it to row 4. See, 6 times this would be 6, minus 6 would be 0. That's what does it for us. Notice if you have a leading 1 here, use the number here with the opposite sign. This was a minus sign down here, so you do a plus sign here, plus 6 here times that leading 1. That will give it to you. Up here, you were trying to get rid of the 2 here, so do a minus 2 times this. Here we're trying to get rid of a plus 1, do a minus 1 times it. Okay, that's the procedure. Okay, now a lot of writing again. We're not messing with row 1 right now, so it's 1, 2, minus 1, 0, 2. We're using row 2, so we're not messing with that. 0, 1, 1, minus 2, minus 3. Okay, now I'm going to be just plumb lazy here. I'm also going to do this. I'll look at this row and notice everything is divisible by 3. So I'm going to do this other step here. I should be waiting, but I'm going to do it now. Row 3 divided by 3, because that'll give us a leading 1 there. 0 divided by 3 is 0. 0 divided by 3 is 0. 3 divided by 3 is 1. Minus 3 divided by 3 is minus 1. And minus 6 divided by 3 is minus 2. So I went on and did that just because I was looking. I didn't want to write it twice. Okay. Now we're going to do row, what we just said to do. 6 times row 1, that is a 1, plus, so that, no, 6 times row 2. 6 times row 2 would be 6 times 0 is 0 plus 0 is 0. 6 times 1 is 6 minus 6. That's also a 0. 6 times 1 is 6 minus 6. That's also a 0. 6 times a minus 2 is minus 12. Minus 1 is minus 13. And 6 times a minus 3 is minus 18, minus 21. Oh my goodness, that's minus 39, isn't it? Yuck, this thing is aggravating. Ooh, I don't like big numbers in there. But the good news is, what do we have to do? Just divide that fourth row by negative 13. Row 4 divided by negative 13. Remember, that's a legal move. Multiplying by negative 1/13. That works as well. That makes this a 1 and that a 3. Okay, so I'm just going to do that and say we did it otherwise. And guess what? Yes?
How did you get 39? I kind of got lost there.
Okay, we're going back here to this part here. 6 times row 2. Row 2 was a negative 3 here. So 6 times negative 3 is minus 18 plus row 4. So minus 18 minus 21. Yeah. I've done this so many times I remember that's what it was. Okay. So then we divide everything by negative 13 and you get a 1 and a 3. So that basically right there tells you, remember, the first column represents x1s, second column x2s, third column x3, fourth column x4, and the fifth column are your constants. So what this is saying, 1x4 is equal to 3. So that tells you x4, x of 4 is equal to 3. Okay? What this row is telling you is x3, that's what that stands for, minus x4, which is minus 3, is equal to negative 2. Well, add 3 to both sides, and that gives you x sub 3 is equal to 1. Okay? Now go up here to this one. This tells you that x2, this is why it's called back substitution, plus x3, well x3 was 1, so plus 1, minus 2 times x4, so that would be minus 6, is equal to minus 3. That's what this row tells you. Well, this is a minus 5. Add 5 to minus 3, and you get x sub 2 is equal to 2. Now substitute everything in here. This top row tells you x sub 1 plus 2x sub 2, so that's going to be plus 4, minus 1 times x sub 3, so that would be minus 3. Nothing times x4 is equal to 2. So this is x plus 1 is equal to 2. Subtract 1 from both sides. You get x sub 1 is equal to 1. I think I just did it in my head. So your solutions you can write as a 4-tuple. 1, 2, 3, 3. Yeah. Let's see if that's what they got. No. Goodness, I messed something up somewhere here, folks. No. I'm sorry. I put in the wrong number. I was looking at this. Back up. Erase. All right. Okay. We got let's get right what we got right. Okay. The 3 we got right. I messed this. X of 3 is equal to 1. Okay. Oh, I may have plugged that in wrong here. X of 2 plus 1. Yeah, we got that right. Minus 6. Yeah. So that one should be right too. Yeah. We got that right. Yeah. It's this one up here I messed up. It's x of 1 plus 2 times x of 2, that's plus 4, minus, and there, I'll look down here and it should have been there, minus 1. So that should have been a minus 1 here. Okay, and that would give us, is that equal to 2? So this would be x plus 3 is equal to 2. Subtract 3, that gives you a minus 1. Yuck! Okay, so that's a minus 1. So there's our answer. Negative 1, 2, 1, 3. Got it. Take your time with this. I just don't have a lot of space, so I skip too many steps. I get too crowded. I don't have that much white space. You have all the space you need. Okay? Now, we go to 12:45, right? So we got 15 minutes. Let's see what happens with example 6. Okay, it's a completely different one. Do I need to leave this here a little longer, or has everybody got it? I'll take that. I got it. Okay, so let's clear the drawing and let's do example 6. Okay. X sub 1 minus x sub 2 plus 2x sub 3 is equal to 4. x sub 1 plus x sub 3 is equal to 6. 2x sub 1 minus 3x sub 2 plus 5x sub 3 is equal to 4. And 3x sub 1 plus 2x sub 2 minus x sub 3, that's supposed to equal 1. Alright, I hope I've written it right. Y'all check me and make sure I don't do anything dumb. Okay, now, first thing you do is translate this to an augmented matrix. It's going to be 1, minus 1, 2, 4. 1, 0, 1. I keep looking at the wrong thing. 6. Let me... Okay. Alright. Next one. 2, negative 3, 5, 4. Last one. 3, 2, minus 1, 1. Alright, what do we want to be first? What you've already got. You want a 1 to be in the upper left. We got it already. We thank our lucky stars. Okay, what do we want next? We want zeros below it. So to get this one to be a 0, minus this, so minus 1 plus that. So minus row 1 plus row 2. Okay? We're using row 1, so we just keep it right like it is. 1 minus 1, 2, 4. Then when you do minus row 1 plus row 2, that becomes a 0. Minus row 1 would be 1 plus 0 would be 1. That's working out nicely. Minus 2 plus 1 be a minus 1. And minus 4 plus 6 would be a 2. Right? Okay, what's the next thing we want? We want this 2 to become a 0. How do we do this? Minus 2 times row 1 plus row 3. Alright, so minus 2 times 1 is minus 2 plus 2 is 0, just like we wanted it to be. Minus 2 times a minus 1 is a plus 2, right? Minus 3 would be a minus 1. Okay. Minus 2 times minus 4, minus 2 times 2 is minus 4, plus 5 is a 1. And minus 2 times 4 is negative 8, plus 4 is negative 4. Okay, I think. Track me and make sure I'm right. And then we want this to be a 0, so minus 3 times row 1 plus row 4. Alright, that would be a 0 here. Minus 3 times minus 1 is plus 3, and 2 is 5. Minus 3 times 2 is minus 6, minus 1 is negative 7. And minus 12 plus 1 is minus 11. Boy, these are some weird numbers. Looks like I'm doing okay so far. Alright, but I can see the problem coming. But we're right so far. Don't think I'm going to have room over there, so let's come down here. And what do we want next? We have a leading one here, zeros below it. We already have a leading one here, good for us. We want zeros below it. So how we get this to be a 0 is just add row 2 to row 3. So row 2, you always use the row with the leading one in it. Row 2 plus row 3. And that'll be it, folks. Okay? So let's do that. We're not using row 1, so we'll write it down. 1 minus 1, 2, 4. We're using row 2, so write it down. 0, 1, minus 1, 2. Now, we're operating on row 3. 0 plus 0 is 0. 1 minus 1 is 0. And then minus 1 plus 1, that's 0. And then 2 plus a minus 4 is a minus 2. Stop right there. Hold your horses. What is that equation right there telling you? No x1s, so that would be 0, plus no x2, that would be 0, plus no x3, that would be 0, is equal to minus 2. Can 0 plus 0 plus 0 ever equal negative 2? No. You don't even need to mess with that fourth row. This is not going to work because this is something that makes no sense. So this is no solution, no matter what row 4 turned out being. Now if that had been all zeros, no sweat at all. Just move it to the bottom. But this is not all zero. This is 0 plus 0 plus 0 is equal to negative 2. Can't happen. Cannot happen. So that one has no solutions. Okay.
We can't even divide it by 2.
You can, but guess what you get then? 0 plus 0 plus 0 is equal to negative 1. Or 1. Or anything else. But the thing is, 0 cannot equal any of those numbers. Don't you see? On the left you have all zeros, on the right you have something that's not 0. If that on the right was a 0, yeah, move it to the bottom, you're okay. But if it's not 0, then you have no solution. There is no way 0 can equal anything other than 0. Okay? No solution. Now, let's get started. Okay, any other questions on this problem? Anytime you come up with something that can never be true, and this can never be true, this represents x1, x2, x3. 0 plus 0 plus 0 cannot equal negative 2 no matter what you do to it. It can't happen. No solution. If it came out 0 plus 0 plus 0 equals 0, yeah, that's always true. So you might wind up with infinite number of solutions, except you had an extra equation anyway. You might still be able to get a unique solution. Excuse me. My voice is going on me again. I think what's happening, I'm getting incredibly hungry. Okay, so let's turn to the top of page 19, and we're going to talk about what Gauss-Jordan elimination is. With Gaussian elimination, you apply elementary row operations to a matrix to obtain a row equivalent row echelon form, just like this. Leading one, leading one, and here you couldn't. Yeah, you get a leading one here, but that still has a solution that makes no sense. Okay, so stop right there, no solution. But that's Gaussian elimination. You get it into row echelon form. The second method of elimination is called Gauss-Jordan elimination, after Carl Friedrich Gauss, who we had before, and Wilhelm Jordan, who lived considerably, maybe a century or more after Gauss did, 1842 to 1899. He continues the reduction process until you're in a reduced row echelon form, and Example 7 will show that. I have a feeling we're not going to have time, but let's get as far as we can on it. Now this example is also located at larsonlinearalgebra.com, and you can see a interactive version of this type of an example. No code required, no key required, just go there. Okay, so let's do example 7. Do I need to leave 6 on here any longer? Anybody? No? Okay. Here's example 7. X, I like seeing that, minus 2y plus 3z is equal to 9. Second equation, minus x, oh that's going to be pretty nice too, plus 3y is equal to negative 4. Third equation, 2x, that's not going to be too bad, minus 5y plus 5z is equal to 17. Somehow something makes me think we've seen something like this before. So we're going to do Gauss-Jordan elimination now. Okay, first thing we're going to do, write this as a augmented matrix. Anyone want to tell me what numbers would go there?
1, negative 2, plus 3, is 9.
Got it. Next.
Negative 1, plus 3, 0, negative 4.
Got it.
Next is 2, negative 5, plus 5, and 17.
I don't like that 17, do you? Okay. All right, let's see what happens. Now, what do we want first? We got it. We got that 1 in the upper left position. That's exactly where we wanted it. What are we going to do next? We want zeros below it. Well, that's going to be easy to get this to be a 0. Just add row 1 to row 2. Row 1 plus row 2. All right. That's going to be fairly simple to do. So we'll write down row 1, 1, negative 2, 3, 9. Add the 2 rows together, you get a 0 there. You get a 1 there, I'm liking this. You get a 3 there, and you get a 5 here. Alright. Now, next you want a 0 here. Well, that one you do minus 2 row 1 plus row 3. Minus 2 row 1 plus row 3. Alright, so minus 2 times 1 is minus 2 plus 2 is 0. Minus 2 times minus 2 is plus 4. Minus 5 is minus 1. Minus 2 times 3 is minus 6 plus 5 is another minus 1. And minus 2 times 9 is minus 18 plus 17, I think, is another minus 1. Make sure I'm doing this right. I think they skipped a whole bunch of steps, okay, because they had done this before. All right. We're out of time, okay? So, do you think you can proceed with this on your own, or do you want to go back and pick up from here next time? You tell me. You want to pick up from here? I was afraid you'd say that. All right, we are out of time. So okay, any questions? Any last questions you may have before we get going on this? Okay. If not, then I'm going to stop the recording right now before I forget it. Okay. So I'm going to